Welcome to Cambridge Chemistry channel with Sarwat Ahmed. Be sure to like the video and subscribe it. Uh, in this video, I will continue the previous quick revision session of 5070. So, I have discussed electrolysis in previous video till this point. Now, state that metals or hydrogen are formed at the cathode and the non-metals are formed at the cathode other than hydrogen, because positive ions are reduced at cathode and non-metals formed at the anode. For example, like molten lead 2 bromide PbBr2, B bromine gas formed at the anode. This is anode product, bromine gas, and cathode product is cathode product is lead. So this is positive ion, metal ion. So this is the product of cathode and this is the product of anode. But if concentrated or dilute, in case of concentrated or dilute solution, concentrated, for example, if the solution is sodium chloride aqueous, so the anode product will be 2Cl negative to form Cl2 plus 2 electron, but cathode product will be hydrogen. So except hydrogen, positive metal ions are formed at the cathode, but in case of dilute or aqueous solution, hydrogen formed, because hydrogen is less reactive than all metals above in the reactivity series of cation. So that's why hydrogen discharge at the cathode. Predict the identifier of products at each electrode for the electrolysis of binary compound. Binary compounds mean molten compounds in which we have two ions like potassium bromide. Potassium bromide has positive and negative ion, two ions only present. Predict the identity of the products at each electrode for the electrolysis of halide compounds in dilute concentrated aqueous solution. In dilute solution, OH ions, anode in dilute solution, anode product reaction is 4OH ion to form 2H2O plus O2 plus 4 electron. But in case of concentrated aqueous solution of halide ions, so this is the halide compounds. In dilute solution, anode product is this and cathode is again hydrogen. But in case of concentrated solution, anode product will be chlorine gas. For example, if chloride ion is present or bromide ion is present, let's say bromide ions are present, to form bromine gas plus 2 electron, and cathode will be again hydrogen. State that metal objects are electroplated to improve their appearance. So this is advantage of electroplating and resistance to corrosion. Please write down these two advantages: improve their appearance and resistance to corrosion. This is second advantage. And electroplating, in case of electroplating, for example, if you want to electroplate with silver metal, so object, like for example, this is the object, this is the rod, this is the object, this is cathode, and this is anode of silver rod. Silver is anode and object is cathode. If silver plating, in case of silver plating, silver is anode and solution is silver nitrate, electrolyte is silver nitrate. So this is the electroplating reaction. Anode reaction is Ag solid dissolved in solution, Ag positive plus electron, and cathode reaction is Ag positive plus electron to form Ag solid. Please follow the same reaction, but you can change the metal if other than silver metal is, if copper, then use copper. If chromium, then chromium is anode and object is cathode, and reactions are just like this. Okay. Hydrogen and oxygen fuel states that hydrogen oxygen fuel cell uses hydrogen and oxygen to produce electricity with water as the only chemical product. You know that water is the only chemical product, and here examiner can ask you that describe the advantage and disadvantage of using hydrogen oxygen fuel cell in comparison with gasoline petrol engine in vehicle. In petrol engine, pollution like carbon dioxide is formed. Pollution products like carbon dioxide and gasoline as well. But in case of hydrogen oxygen fuel cell, water is the only waste product, only which does not cause pollution, is the only product which does not cause pollution. And this is the diagram of the hydrogen oxygen fuel cell. This is the porous spot, and on this side hydrogen gas is provided to the fuel cell, and on this side oxygen gas. This is the diagram of hydrogen oxygen fuel cell. These are the two electrodes. Platinum electrode which is connected with bulb. So water electrolyte is potassium hydroxide. So reaction is, anode reaction is for hydrogen gas fuel cell, H2 plus OH negative to form water plus 2 electron, 2H2O, 2OH, and cathode reaction is oxygen gas plus 2H2O plus 4 electron to form 4OH ion. So at anode oxidation takes place, at cathode, and anode is an electron flow from hydrogen gas to oxygen gas, NO2. This is anode and this is cathode. Hopefully to understand. Next topic is chemical energetics, exothermic and endothermic reaction. Exothermic, in which heat is given out, endothermic, in which heat is taken in, or heat is absorbed. State an exothermic reaction transfers thermal energy to the surrounding, leading to the in endothermic surrounding energy is decreased, and in exothermic surrounding energy is leading to an increase in the temperature of the surrounding. In exothermic, temperature is increased, surrounding temperature is increased, and endothermic surrounding temperature is decreased. State an endothermic reaction takes place in thermal energy from surrounding, leading to decrease in temperature of the surrounding. Endothermic, this is written, this is very important to know. So all these things are written. Take in thermal energy from the surrounding, leading to decrease in temperature of the surrounding. You should know this. State that the transfer of thermal energy during a reaction is called the enthalpy change. This is the enthalpy change of the reaction. Delta H is negative for exothermic reaction and positive for endothermic reaction. Define activation energy, minimum energy. This is the definition. Beta, please do write this definition. Minimum energy that colliding particle must have to react. This is the minimum energy examiner is expecting from your side. Please do learn this in a definition. Draw, label and interpret reaction pathway diagrams for exothermic and endothermic. This is the exothermic diagram. This is enthalpy change. This is activation energy from reactant to, and please arrowhead is towards this this is activation energy, and arrowhead towards the product. This is product. This is exothermic. Over here energy unit is kilojoule per mole, and over here progress of reaction. At x-axis progress of reaction, and at y-axis energy. So activation, and this is delta H, enthalpy change, and this is endothermic reaction. This is enthalpy change. This is enthalpy change, and this is activation energy, delta H, reactant and product, and progress, similarly progress of reaction and energy. Now you should know A, B, C and D, and along with this 5 marks, this diagram carrying 5 marks. You should know that where reactants are written. This is these are the bonus marks. Okay, products, enthalpy change of the reaction, activation energy. This is for exothermic, and this is for endothermic. And x-axis also examiner want to label x-axis and y-axis. At x-axis write down energy, and at y-axis write down the progress of reaction, and second over here with passage of time, kilojoule per mole. So this is energy profile diagram. State that bond making is endothermic process, bond breaking is exothermic process, and explain enthalpy change or reaction in terms of bond breaking. And so please this question carrying 2 marks, and 2 marks when you write down bond breaking is endothermic, and bond forming or bond making is exothermic. Bond breaking absorb energy, and bond forming and bond making released energy. If reaction is exothermic, in case of exothermic, so write down, so why reaction is exothermic, write down bond making release more energy than heat absorbed in bond breaking. So this point carrying 1 mark, carrying this line, and this carrying another mark. Please write down these 2 points, make sure, and this will definitely come in exam. So that's why this is a very important question. In every year this will come in, this question will be assessed, or this question definitely will be assessed in 2024, because in previous all years you have seen that this question is assessed by the examiner. Chemical reactions, next topic is chemical reaction. This is also very important reaction, physical and chemical change. Identify physical and chemical change and describe the differences between them. Chemical change during the chemical reaction, which the change take place. In physical change, that heat loss, heat gain, this is the physical change. And physical also, the color change, gas is evolved. So these are the physical and chemical changes. Describe the differences between them. Rate of reaction. Describe collision theory in terms of number of particles per unit volume. Always write down number of particles per unit time, frequency of collision between the particles, kinetic energy of the particles, activation energy. State that a catalyst increases the rate of reaction, decreases the activity. So this is written in the this factor. Look here. What is the effect of rate of reaction? What is the effect of catalyst on rate of reaction? Catalyst increases the rate of reaction, decreases the activation energy of a reaction, and is unchanged at the end of reaction. This is the catalyst effect. Please write down like this. Increases the rate of reaction. You can write down by lowering the activation energy or using itself, without using itself, or and is unchanged at the end of reaction. Describe and explain the effect on the rate of reaction, changing the concentration, increasing concentration. By increasing concentration, reaction is increased. Why it is increased? Particles become crowded. Number of particles become crowded per unit volume. And have more successful collisions. Similarly, changing the pressure of gas only the effect of pressure only in case of gases. So if there are gases, by increasing pressure, volume is decreased by increasing. So this is about the concentration. By decreasing, vice versa, by decreasing the pressure. Now by increasing temperature, by increasing pressure. Pressure is inversely proportional to volume. So by increasing pressure, volume is decreased, decreasing pressure, volume is increased. So you have to write down like this: by increasing pressure, reaction is increased, rate of reaction increased as particles come closer to each other and have more particles per unit volume. Hence, have more successful collision between the particles. Collisions between the particles. Changing the surface area of the solid, this is the lump, this is the granules and powder. In powder the rate is fastest, this is powder, fastest rate, granules moderate and lump slowest. So by decreasing the size of the particle, rate of reaction is increased. So you can write down, by decreasing the size of particles, surface area of solid is decreased, surface area to volume ratio, but particle size is decreased, but surface area to volume ratio is increased. By increasing the surface area of solid, by increasing the surface area to volume ratio of solid is increased, the rate of reaction is increased, because particles are because more particles exposed as by increasing the surface area of solid particles, surface area to volume ratio of solid particles, area to volume ratio of solid particles are increased, rate of reaction is increased, because more particles react with each other per unit volume and have more successful collision with more successful frequency of the collision. So if lump is there, so there is less surface area to volume ratio. If powder, this is more surface, so that's why with powder fastest, with moderate, and it is with lump it is slower. And you know, if you identify the rate of reaction with graph like this, this is powder, a lump, this is granule, and this is for powder. Describe and evaluate practical method for investigating the rate of reaction including change in mass. So he always in previous 2023 May June paper, there is a question in which examiner asks you to find out that how to measure the rate of reaction other than including formation of gas. So investigating rate of reaction including the change in mass of reactant or a product and the formation of gas. So this is the volume of gas or product. This graph is for volume of gas or product you can use or you can identify, or mass of product. And over here time unit is second, over here volume unit is centimeter cube, and mass unit is gram. If mass of product, so over here gram, but if volume is there, then centimeter cube, write down unit in bracket as well. So this is the graph of mass of product. This is the slowest and this is the fastest. If you increase the concentration of the of the excess reactant, if you increase the concentration of limiting reactant, the graph like this. So if you increase the limiting reactant, so this is graph, different moles are formed, but you increase the excess reactant, then graph like this. And this is the mass of product or volume of graph, and this is the reactant used. And if you ask to draw the another curve by using catalyst, so graph like this. This line is for without catalyst. This is the mass of reactant used. And this is time. Without catalyst, this curve for without catalyst, and this is for with catalyst. So next topic is reversible reactions and endothermic reactions. State that some chemical reactions are reversible as shown by the symbol. This is the symbol of reversible reaction. Describe how changing the conditions can change the direction of reversible reaction. The effect of heat on hydrated compound. For example, this is hydrated compound. CuSO4.5, this is hydrated compound. If you heat this compound, this is the reaction like this. This is hydrated and this will become anhydrous plus 5 moles of water. And on heating, if you add water, so this reaction will be reversed back. The addition of water to anhydrous compound. If you add water, this is reversible. Hydrated to anhydrous is forward reaction, and when you add water and salt become hydrated, so this will be reverse. So you should know this is also very important reaction. This is for in case of cobalt chloride as well, and copper 2 sulfate. Cobalt 2 chloride, similar reactions. Cobalt 2 chloride, this is anhydrated, this is blue in color, and anhydrous it is white. But in case of copper 2 cobalt 2 chloride, this is blue, this is pink, and this is blue. This is formula of cobalt chloride hydrated, pink in color, and when you heat, water is going to evaporate, and this will be blue in color. This is anhydrous without water. Sorry, without water. This is without water, and this is hydrated. Anhydrated with water, it is pink in color, and so you should know both of these compounds. State that reversible reaction in closed system is equilibrium. Equilibrium reaction takes place in closed system, and these are the 2 points. The rate of forward reaction is equal. What do you mean by dynamic? Write down. The question is write down 2 points of dynamic equilibrium. This is dynamic equilibrium. Reversible reaction is the reaction which takes place in closed. This is the definition of reversible reaction which takes place in closed system. And write down what is dynamic equilibrium. Dynamic equilibrium, this is the definition of 2 points of dynamic. The concentration of reactants products are no longer changing. These 2 points, and you are supposed to write down like this. So please learn these 2 points. This is very important topic, and this is always assessed in the exam. In previous past papers you have seen, and this can be assessed in 2024 as well. So this is the definition of write down 2 points of dynamic equilibrium. Please learn these 2 points. The rate of forward reaction is equal to the rate of reverse reaction or backward reaction. The concentration of reactants and products are constant or no longer changing. Predict and explain the reversible reaction, how the position of equilibrium is affected, changing the temperature. If reaction is like this, N2 plus H2 to form 2NH3, this is reversible reaction. This is reversible reaction, and you know that over here negative delta H. In this case, forward reaction is exothermic and backward reaction is endothermic. So if by increasing temperature, reaction will by increasing temperature the equilibrium will shift backward, will shift backward, direction is backward, as reason is as backward reaction is endothermic. and vice versa by decreasing temperature, because increasing temperature favors the endothermic side and decreasing temperature favors the exothermic side. Please write it down. Please write like this. And you should know that again I will repeat this sentence, that increasing temperature favor the exothermic side, decreasing temperature favor the increasing temperature favor the endothermic side backward, and decreasing temperature favors the exothermic side. Changing the pressure, increasing pressure, equilibrium will shift the side with less number of moles, with less number of moles of molecules, and vice versa with decreasing pressure. If pressure is decreased, then equilibrium will shift the side with more number of moles. Changing concentration, for example, if you increase concentration of ammonia, reaction will shift backward to counteract the change or to balance the change. And if reactant sides hydrogen is increased, the reaction will shift forward, making more ammonia. Okay, so by changing concentration, if products are increased, then equilibrium will shift backward, and if reactants are increased, it will shift forward. But in case if ammonia is decreased, reaction will shift forward, and if reactants are decreased, reaction will shift backward. So please keep it in mind, these things, these points. Using catalyst only prevail the equilibrium condition, yet that dynamic equilibrium reached earlier by lowering the activation energy without using itself. State the symbol equation for production of the ammonia in the Haber process. This is the simple chemical equation. You should know the sources of nitrogen and hydrogen. Source, this is very important, nitrogen from air through fractional distillation. And source of hydrogen from cracking of oil. You can write down cracking of hydrocarbon, and this reaction is very important to learn this reaction by heart. Cracking of oil. So state the source of hydrogen and nitrogen in the Haber process. Source of hydrogen is methane and nitrogen. Write on methane because in content it is written methane, so you should write down methane. Don't write down oil. Cracking of methane. And this is the condition of Haber process. 450 degree centigrade pressure, 20,000 kilopascal or 200 atmosphere. Write down this figure, 200 atmospheric pressure, and iron as a catalyst. Carrying three conditions, you must learn these three conditions. Iron as a catalyst, 200 atmospheric pressure, and 450 degree centigrade. So just learn these three, 4 points in case of ammonia process or Haber process. This is very important. Please state the symbol equation for the conversion of sulfur dioxide to sulfur trioxide in the contact process, like sulfur dioxide. This is the key stage. and you know that the different first stage is sulfur plus oxygen to form sulfur dioxide. Second stage is sulfur dioxide, this is key stage, plus oxygen to form SO3, this is reversible reaction. And in this case you should know that 450 degrees centigrade is temperature, 200 atm pressure, and iron as a catalyst. So next stage is sulfur trioxide diluted with concentrated sulfuric acid, H2SO4, to form oleum, H2S2O7, and then fourth stage H2S2O7 diluted with water to form H2SO4. Please learn these four equations. This is oleum. This is oleum, OLEUM. Okay. State and the sources of sulfur dioxide: burning of sulfur or roasting of sulfide ores. This is the source of sources of sulfur dioxide: burning sulfur or sulfur. You can write down sulfur and oxygen in the these are the two sources, sulfur and oxygen. First is sulfur, second is oxygen, and these are the condition: 450 degrees centigrade temperature, 200 kilopascal or 2 atm. Write down 2 atm, just 2 atm, 450 degrees centigrade, this is first, this is second, and vanadium 5 oxide as a catalyst, and formula of vanadium oxide is V2O5, and this is commonly asked by the examiner in the first question, in which oxide used as a catalyst in contact process or in making sulfuric acid. This is also in that context is very important. Explain in terms of the rate of reaction and position of equilibrium why the typical conditions stated are used in the Haber. Similar explanation as we have discussed earlier in reversible reaction: changing temperature, changing pressure, changing concentration using catalyst, and contact, including safety considerations and economics. Like we are using catalyst in both process, which save energy because catalyst lowers the activation energy and the dynamic equilibrium reached earlier. So this is the economic condition. And increasing pressure is also taking when we increase pressure in the case of Haber process, it also increases cost. So 200 atmospheric pressure is compromising pressure, so that's why at this pressure that this process is cost effective. So you should know like this, including safety considerations and economic issues. Next topic is redox. This is also very important. 2 to 4 marks from this topic is assessed in every year, and it definitely assessed in this year. So use a Roman numerals to indicate the oxidation number of an element. You should know all elements and molecules and compounds have zero oxidation state. Compounds have zero oxidation state or zero oxidation number. Element 0, oxidation compound 0. Like for example, chlorine 0. If chloride ion, the oxidation number is -1. For similarly copper 2 ion oxidation number is +2 and copper solid oxidation number is 0. Please be careful while writing the oxidation number. Define redox reaction as involving simultaneous reduction and oxidation. This is the definition. Define oxidation in terms of gain of oxygen, loss of electron. Gain of oxygen is oxidation, loss of electron is oxidation, and increase in oxidation number is oxidation. Loss of oxygen is reduction, gain of electron is reduction, and in terms of, you should know that gain electron elements are reduced, lose electron elements are oxidized. A decrease in oxidation number, this is again reduction. So these are the reduction reactions. Identify redox reaction as reactions involving gain and loss of oxygen, gain and loss of electrons. Identify redox reaction by changing oxidation number using the oxidation number of elements in their uncombined state is 0. This is written, all these points are written over here. The oxidation number of monatomic ion is the same as the charge on the ion. For example, chloride ion, the oxidation number is minus. Sodium ion, oxidation number is plus. Sodium metal, oxidation state is 0. Chlorine molecule, oxidation number is 0. The sum of the oxidation number in a compound is 0. Compound is 0. For example, we have CuSO4, oxidation number is 0. The sum of oxidation number is an ion equal to the charge on the species. For example, sulfate ion. So the oxidation number of this ion is equal to -2. And how to find out? This is taking X plus number of atom 4 and oxygen, its individual charge is -2. So 4 minus 2 is equal to -2. X minus 4 to the 8 is equal to -2, or X is equal to -2 plus 8. So X is +6. It means sulfur has +6 oxidation. You can find out ionic species, charge of ionic species like this, or charge of ionic species like this. If you want to know the oxidation number of this compound, this is +1 -2, 1 plus X minus 2, KMnO4, 4 number of atom, -2 is equal to 0, 1 plus X minus 8 is equal to 0, X minus 7 is equal to 0, or X is equal to +7. In this way you can calculate the oxidation number of such compounds and oxidation number of ionic species and oxidation number of covalent compound. Define an oxidizing agent as a substance. This is the definition. All definitions are written down. You just write down from here. Oxidizing as a substance that oxidizes another substance and it reduced itself. Define reducing agent as a substance that reduces another substance and itself oxidized. Identify oxidation, oxidizing agent, reduction and reducing agent, and redox reaction. For example, this is the reaction zinc, CuSO4, zinc sulfate plus Cu solid aqueous and solid. This is zinc solid plus Cu2 positive ion, aqueous ionic equation for this reaction. Zinc 2 positive plus copper solid. Copper, so it is oxidized, oxidation reaction, species is oxidized, act as a reducing agent. Similarly, copper ion to copper solid, this is reduction because gaining of electron, reduced, and oxidizing agent. And you know that the half equation for this reaction is zinc solid to form zinc 2 positive 2 electron, copper aqueous plus 2 electron to form copper solid. So when we cancel these 2 electrons, we write down like this. So this is ionic equation for this reaction. These are the half equation. This is oxidation and this is reduction. These are two half equation. If we cancel the electron, so in this way we identify the oxidation, oxidizing agent, reduction and reducing agent in the redox reaction. Next most important topic is acid, bases and salts. We have how many topics left? 9, 10, fertilizers, organic chemistry. So experimental technique, separation and acids and bases. This is very important that aqueous solutions of acid contain, this is the definition of acid, that substance which contain hydrogen ions, and aqueous solution of alkalis contain OH, and this is very important. Alkalis contain which ions are present in alkali solution, which ions are present in acid solution. This is an acid and this is an alkali or base. Hydroxide ions. Define acids as a proton donor. Hydrogen is also known as proton, so it is also, you should know, define acid as a proton donor. This definition is very important. This is addition of the topic in new scheme of study, so this will be assessed. So acid is a proton donor. Hydrogen is also known as proton donor. This is proton donor. Proton, and acid is proton donor. This is acid is proton donor and bases as proton acceptor. This definition are very important. Please learn this definition. State that bases are oxides and hydroxides of metal, and that alkalis are soluble base. So this is base, soluble and insoluble. Soluble base are hydroxides, alkalis, and insoluble base, example which are insoluble in water, which is soluble. Alkali base group 1, lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, francium hydroxide. These are soluble base in group 1 and these are soluble base in group 2. Calcium hydroxide, strontium hydroxide and barium hydroxide and radium hydroxide. So these are only alkalis in your syllabus. These are soluble base, and insoluble is all other metal oxide. And typical base is FeO2O3 insoluble, CuO, magnesium oxide, any other metal oxide, for example Ag2O can considered as a base, and other odd transition metal oxide, vanadium oxide, V2O5, these are termed as insoluble base. All other metal oxide which are insoluble. So these are the insoluble base. So I will make another video for you So my battery gone dead, so we'll continue.